So this last video for this section, we compute the composition of a trig function with an inverse trig function that's the inverse of a different trig function, So compose a trig function with the inverse of a different trig function. So they don't cancel, definitely. So first you draw the appropriate triangle in the correct quadrant of the CS plane. That's where the unit circle is. Then you label the two given sides, and then you compute the third side using the Pythagorean theorem, because it's a right triangle, so that shouldn't be a problem. And then you find the solution from the triangle by using ratios of two sides from the original definitions of the trig functions. So for example, find cosecant of cotangent inverse of -2. Remember, cotangent inverse of -2 is an angle. So arc cotangent is an angle. So I'm going to set it equal to theta. I'm using theta for my angle. You could use x. I just like to use theta. So theta equals cotangent inverse of -2, and that means that cotangent of theta equals -2. Now cotangent is defined as adjacent over opposite. It's 1 over the tangent, right? Tangent is opposite over adjacent. Cotangent's adjacent over opposite. So that means, and then we need to break the -2 into a fraction. So it can be -2 over 1 or 2 over -1. These are two different triangles. So there's -2. Remember, that's the adjacent side. It says adjacent here, adjacent. So that's this way. That's the C. It's -2 and then 1 for the opposite side. Opposite of the angle that's centered at the origin, right? There, and then the hypotenuse will go there. Then the other one, I have +2 and -1, and the hypotenuse goes there. Now I need to know which triangle is it. Well, the cotangent inverse has a range, and this angle has to be within the range of the cotangent inverse, because I'm saying that theta equals cotangent inverse of something, right? So where is the range of cotangent inverse? Well, it'll be this one, and I'll show you in a second why. So remember, this was the picture that I had a few videos back of the range of the cotangent inverse. These are really good to remember, these little pictures. So it has to be in the upper half plane. It has to be up here, quadrant 1 or 2. It can't be down here in quadrant 4. So it has to be this one. That's in quadrant 2. Okay, so I know which triangle it's going to be. And then h, I can calculate just using the Pythagorean theorem. H is the hypotenuse. So h squared equals the quantity -2 squared plus 1 squared. So h squared is 5, so h equals square root of 5. Okay, now just draw the triangle without all the other junk, right? So I just recopied this triangle and just put the square root of 5 in there. Now I can find any trig function of this angle here. So it says cosecant, which is 1 over sine. Sine is opposite over hypotenuse. So cosecant is hypotenuse over opposite. So it's square root of 5, and that's my answer. Cosecant theta equals hypotenuse over opposite equals square root of 5 over 1 equals square root of 5. Ta-da! So that's how you do that kind of problem. Don't try to cut corners on this. Don't try to do it without drawing pictures. Draw the pictures and get used to the pictures, and that way you'll have a visual memory of how these things go.